Hi everyone, welcome back to another video of 100 Days of Coding by CSI chapter VIT-AP. I am your speaker today, Devarshi, and today we are going to learn about recursion. So, before starting the video, here's a small disclaimer that I'm not going to be covering this recursion totally because recursion is a big concept and you guys will learn about recursion more thoroughly when we will teach you DSF or you guys will learn DSF from anyone else or anyone. There you will understand what recursion is because recursion is a big topic. It has a huge implementations and also there are so many nice problems we can solve using recursion. So many hard problems you can solve using just 10 or 12 lines of code. So it is a huge topic. But here in this video, we'll understand what is the basic concept of recursion, what recursion is to its core. That is what we will learn here. So your base will be strong. Now, what is recursion? Recursion is a function. You guys have just learned function. So recursion is a function that calls itself. This phenomenon is called recursion, right? So how it happens is you guys are given a problem. Now to solve that problem, we are defining a function. Now that problem is a huge problem. There are so many tasks. Using recursion, you break that task into smaller tasks. Right? That's how this recursion thing happens. So basically, what happens is you have a bigger task. You do something and you pass that same task but with smaller parameters, with smaller amount of people. So some task is done. Other task is to be done by that function with but with smaller parameter. Here also, right? So if you want to understand it more easily, I'll tell you. Suppose there is a problem, there is a task that has to be done by 100 people. Now, what you thought, okay, my part, what is my part in that 100 people task? This is a collective task, but everyone has to do it individually. So if you think from your perspective, you will just do your work, right? And you will let others do their work. So recursion actually works that way. In each recursion call, it does its work, that recursive function does its work, and it leaves the other work to the rest of the people. Right? So that is how it actually works. There are 100 people, you will do your work, and you will do the same work to the other 99 people. So this is how this works. Then another people will do its work and dump it to the other 98 people. So that's how this will get shrink, and finally there will be zero people left. That means each people have done their work and the entire work is finished. So that is how this recursion works, right? So there are usually two parts in a recursion. That is, one is the base case and another is the recursive case. A base case is where there is a condition at which this recursive calls will stop. This calling, that function calling itself, this phenomenon will stop. At the particular condition where it stops, that condition is called the base condition, and that case is called the base case. Like in this problem, in this situation we were talking about, here, when will this process stop? This process will stop when the number of people becomes zero from 99, 98, 97, 96, 95. When eventually it turns out to be zero, that is when this process will stop. So there can be other conditions for other problems, right? Based on that, we have to find that condition. Otherwise, what will happen? It will go on for an infinite time. If there is no particular point where it will stop, it will go on infinitely, right? So that is a thing I explained. I also explicitly mentioned here. If there is no base case, then there will be infinite calls. Right, I will tell you about this stack explosion. You will understand it. Although this is the kind of thing that you might not get it now because you might not have that much knowledge about call stacks and how those things are located in the memory. But I will try to explain it in a brief as possible. Okay, so if we just first look at the code here, Uh, this is a function, and as you can see, this function inside of this function is calling itself with a different parameter, of course. If you call with the same parameter, then there won't be any progression, right? You are just calling that function and that function. There won't be any progression. That's why you are changing the parameter, but you are calling the same function. So that is how recursive codes are written. You write a function, you do some work, and you tell, or basically you dump others to do the same work. So for n, it will print this, and then it will let others print that same thing, do the same thing. And when will it stop? When this n turns out to be 0, that is when this function will stop. Now, when a function stops, when you return that function, I hope you guys already know this. Uh, I think it was previously taught in the functions video. When a function stops working, it stops working when that function is returned. So that is why when the base case hits, we usually return that function. Now here, because there is nothing to be returned, that is why we are returning as a void. But as it is returning, that means this function will stop whenever this n will become 0. Okay. So if I want to draw, I can draw it this way. So first, uh, there's a function. Okay. This function first, it will have n. Okay. Then it will be f of n minus 1, right? It will do some work, right? Then similarly, uh, it will call f of n minus 2, right? And so on. So on up until n reaches 0. Till that much, this thing will go on and on and on. I hope this is clear. Okay. So this is how recursive functions work and recursions work. So again, as I'm saying, this is a huge topic. You guys won't get it as easily. You guys will eventually understand everything when you will work on the recursive problems on DSA, or you will work on graphs and trees, the different data structures. When you will work on those things, then you will completely understand how recursion works. You will learn backtracking and all these things. These are advanced concepts. I don't want to overwhelm you with these words. But this is the basic concept, a function calling itself a function where some work is doing in that part, then you are passing or you are telling others to do the same work. But that is none of your concern. They will do it. That is the basic concept or basic mindset that you have to have when you think, okay, this problem can be solved with recursive approach. Right. I will show you some examples, some basic examples where you will understand. Okay. Recursion uses call stack. I'll briefly explain what is this call stack and what it means. So basically, in a computer memory, in a CPU, there are two things inside a RAM, which reads the memory, which loads the data. There are two things there. Basically, two things mainly. There are other things as well, but basically, these two kinds of memories where data is stored temporarily. One is called a stack, and the other is called a heap. These two are data structures, by the way. Uh, inside of stack, I think some of you already know how stack works. It is a last in, first out, LIFO structure where whatever gets inside of stack, whatever gets last. I mean, think of a wedding house where there are plates put there. You have to take one plate from there. So what do? You take a plate from the topmost of that stack, right? So that is also called a stack, obviously. So that is how it works. You take out the topmost or the one that is entered at the last. So last in, first out. That is how stacks work. So actually, what happens is whenever you call a function, it actually gets stored inside a stack. another function is called inside of the stack. It is not returned yet. So it will be over there. When you return a function, it gets out of the stack. That means this function is stopped. Then this function will execute. Again, when this function returns, it will get out of the stack. So it will stop. So this is how stacks work. Now there is a line I wrote here that if there is no base case, then there will be infinite calls. Infinite calls means no call is getting returned. And there are just calls happening. So what happens is eventually there is a space, of course, there is a space for RAMs and CPUs, everything, right? So if this stack gets filled, like there are no space left for another function to be there, and recursive call just calls another function. So what happens is it will throw an error. It will throw that stack out of bound error or stack. This is a term called, I'm forgetting that term. So that will happen. So basically, what will happen is your stack will get full. There won't be any more space to insert another function or any other thing. So okay, I remember that is called stack overflow. So that will happen. It will overflow. Okay. So that is why we use this base condition so that this situation does not occur. All right. Now I will now I will tell you about some problems where you can think, okay, so when I see a pattern like this, I will think of a solution that will have recursion in it. So think of a sum of a number. In your question, it is given you have to find sum of 10 numbers, 10 natural numbers. Okay, what does that mean? It means 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on till plus 10. That's what it means, right? So, okay, if you think about this problem, you can do it manually as well, right? Or tell computer to go from one, like run a loop and go until this like this, right? It is a iterative approach. You can do it using that as well. But it will be easier if you're thinking like that. Okay, 10. Ultimately, what are we doing? We are doing operation which is a plus operation between two operands. Okay, one is 10, then there is 9, there is 8. So think about it like this. If we take this summation of 10 natural numbers, if we want to do this task with a function called f of 10, right? Inside of this, we'll line that code. Now, in this code, if you think, okay, let me do it this way 10, do your work, then we can say, okay, the other 9, because the function will have the same concept, right? The whatever is written inside that function, it will have the same operation. So now we'll say, okay, let's do that same operation, but now with 9 natural numbers. It will be same, right? If we add 9 natural numbers and then add 10, we'll have the same as adding up 10 natural numbers. Sorry. So this is how this thing is happening. Now for f of 9, we'll think similarly. Okay, let's do 9, then 9 plus f of 8, right? Works same. So this is how it will happen, and after everything, you will have the final answer in your f of 10. Right? This f of 9 will return something, right? And it will have your final answer. So can you see a pattern over here? This is called the recursive equation. So the final equation is what? For whatever value of n, if we add n plus the f of n minus 1, we have the solution. So this is the recursive call that we have to do after each function, right? And like it will be actually like this, right? Similar kind of function in a fn function, the code will be like this, right? If okay, when will it stop? It will stop when n will turn to be 0. When this will happen, we will simply return. But if this does not happen, what we will do? We will simply return. Let's store this value somewhere. Okay, let's do something like this. Let's have a value val. Can do it many way actually. I'm trying to show you the easiest one. Let's put a value over there. Let's define val as 0. Right, it will be our accumulator. Now at each operation, we will do something like this. At each operation, we will val plus equal to whatever the value of, sorry, whatever n is, then we will simply call it like this, f of n minus 1. And after everything, we will return that value, right? Because this value, when after everything, it will save the total addition. So this will happen. Otherwise, there is other approach as well, where you can directly return this, directly return f of n plus f of n minus 1, just like we wrote over here. This, but then you have to return 0 for the zeroth operation. When I mean when f of 0 means there is zero natural number. That means you will return 0 because what will you plus with? So you can think this as well. Then you will remove that. Then there is no need for this, right? So you can do it this way as well. It also works the same way, right? When the n will turn 0, they will return, or otherwise you will just follow this recursive equation. You will return this, and it will work same. Now factorial, also the same thing. What is the factorial of 5? It is 5 into 4 into 3 into 2 into 1, right? So again, same thing. If you think of it like this, and if you can observe this, it is simple. F of n equal to n. You do your part, and then you let the others do their part. N minus 1. I think you can see how this pattern is following, right? So again, it will be same code, but here it will be when n equal to 1, you will stop this call, because if you return 0, then what happen is your entire operation will, like, anything into a 0 is 0, right? So that's why you cannot return 0 there. You will stop the recursive call when the value will be 1. You will stop it there and you will return 1. And here also you will multiply, right? So this is a simple recursive function in order to get the factorial of any number. Again, simple math, simple, just to observe, right? Any recursive problem can be solved. First approach should be your observation. How you observe that problem. Can you notice this pattern following? Any kind of patterns forming? That is the first cue. A Fibonacci. What is a Fibonacci? Fibonacci sequence is 0, then 1, then 0 plus 1, 1, then 1 plus 1, 2, then 2 plus 1, 3, then 3 plus 2, 5. Right? The last two numbers are added always. Right? And like this. So this is the Fibonacci. Now, if you observe it carefully, so what did I say? We say any number is addition of its previous two numbers. So you can just literally see it and find the recursive equation. And once you get the recursive equation, it's done. Right? It's done. So what is the base case here? As you can see, so the base case for 0 and 1 we know. Whatever for, because we always we know the first two value of a Fibonacci sequence, that is 0 and 1. So that's why the base case will be when f equal to, okay, let's me write it. This, if n equal to 0 or n equal to 1. Okay, I was writing, sorry, I was writing Java or any other syntax. So for n equal to 0 or 1, we will return n. right? Whatever. If it is 0, then we will return 0. If it is n, we will return n. Simple. We will return 1, right? So, but if it is not like this, then what we will do is we will return f of n minus 1 plus f of n minus 2. Okay, so that is how this will work. If I try to draw it, if you want, I can do it for 8, for let's say 5, it will be simpler. For 5-digit recursive or like Fibonacci sequence, how it will be for 5? Okay, next up, it will call 4 and will call 3. Okay, now for 4 it will call 3 and it will call 2. For 3 it will call 2, it will call 1. For 2 it will call 1, it will call 0, right? Similarly, for 2 it will call 1, it will call 0. For 3 again, it will call 2, it will call 1. For 2 again, it will call 1, it will call 0. So this tree will form, and what will you get? For 0, you will have, okay, let me write in some other color. For 0, you will return 0. For 1, you will return 1. Now 1 plus 0, here the return value will be 1. So if you notice clearly, for the 0th element it is 0. So first element is 1. For second element it is 1. And as you can see, for second element of the Fibonacci sequence, you are getting 1. So this is how it is forming. Okay. Now let's do this. For 1, we already did the base case. For 1, we will return 1. So here it will return 1. Now 1 plus 1, you will have 2 here. You will have 2 here. Can you see for third value it is 2. Right? So this is how this entire thing will form, and finally you will have your fifth value of this recursive function here. So this is how this entire thing works. You break this big task into smaller tasks, and finally you have your final answer. Okay, so this is how recursion works. I know it might not be that simple, so I ask you guys to research a little bit, do a little more chat GPT. Okay, and don't worry, you guys will understand it completely when you will solve more DSA questions, when you will do recursion thoroughly, because I took almost 1 month to understand recursion fully. So it takes a lot of time. Okay, but you need to give that time because you need to have all this visualization inside of your head. That is when you'll actually understand, okay, how this is actually happening. When you will able to see these patterns, whenever you see a problem, that is when you will finally understand, okay, this is how recursion works. So it will take time, but don't worry. I hope you understood the basic concept, how it works, right? So that's it, guys. I think it's done. So the basics are done. So thank you for listening. We'll meet again in another video, right? So till then, bye bye and happy learning.